In this lesson, we're going to look at vertical and horizontal translations of the sine function. I kind of think that you might like this because it's going to be very similar to graphing quadratics. And so some of these skills are going to seem very familiar, and you'll probably catch on to this pretty quickly. In previous lessons, we learned what the sine function looks like and the cosine function, although we are really just focusing on the sine function for this course. So a vertical translation, we've seen this before. When you have this plus or minus number at the back of your equation, that number is going to tell you to move the sine function either up or down vertically. So it's kind of, if c is greater than 0, you're going to move the function up, and if it's less than 0, you're going to move it down. Something else that we can look at is a horizontal translation, or a phase shift it's called, just moving the graph of sine theta right or left. This is also going to be very similar to what we've seen with quadratics, and also again kind of annoying and hard to remember, but this so that number is going up and down. This number, when it's inside brackets, when you see brackets, again, that's going to mean that we have a horizontal translation. And when the number is negative, it's actually going to tell you to go to the right. So here, that would be telling you to go to the left. Here would be right. So it's always the opposite direction as what we see. So example 1, graph the function g of x equals sine x minus 3. So our sine function, first of all, the way that we like to set up the graph paper, or the way that I'm used to doing it anyway, is this would be 0, and we're going to do one full rotation up to 2 pi. So if we think of 30, 60, 90, these are sort of our key points. We do pi over 2, and then this would be pi, so that's only 180. This would be 3 pi over 2, and then this would be 2 pi. When I have some room, I like to space out my numbers vertically as well. So maybe that's 1, and this could be 2, and this could be 3, because I know we are going to move this function down 3. So what I get used to doing, which I find really helps me, is sketching the original sine function. So our root function starts at 0, at 90 we're up to 1, we're back to 0, we're down to -1, and we're back to 0. So we get pretty fast at graphing that. Now, if this equation has a -3, it means we're just going to move that function down 3 units. So what has happened? This becomes our horizontal axis. There is our function g of x equals sine x minus 3. So it does really help to have this reference drawn in up above. I think it helps me know what to do. What are the domain and range of the new function? So domain, since this function is going to go on and on forever in the left direction and to the right, our domain for all of these sine functions will be the set of x such that x is an element of all real numbers. The range, though, is a little bit different. So this is going to repeat because it's periodic. We are going up to -2 and down to -4. So the range would look like y such that y is going to be in between -4 and -2. And y is an element of all real numbers, meaning all of the decimals and fractions in between. And then state the equation of the horizontal axis, the amplitude, and the period of the new function. So the horizontal axis is at -3 because this becomes our axis for our function, our horizontal axis, at y equals -3. The amplitude is going to be 1 because still this is only going up 1 unit to the maximum point from the horizontal axis. And the period is still repeating in one cycle. It's starting at 0 and it finishes one cycle in 2 pi radians, or 360 degrees. Example 2. Maybe this looks a little different. You might have pi over 3. You might see this in radians. You might also see this in different textbooks. This might just be written as 60 degrees, pi over 3. And refer to your unit circle because that always helps with work like this. So again, what I think I would do first is graph the root function. So there's our original sine function. And then what this means here, we have to remember if we see brackets, that is horizontal translation, and we're going to go right 60 degrees. So pi over 3, what does that actually mean? Well, remember that we're counting 30, 60, 90. So if I have to go to the right, all of my points are going to be translated basically 2 squares 60 degrees to the right. I just go to the points that I know, these main points. Here I know goes through the x-axis, so if I go right 60 degrees, it would be there instead. This point is going to go to here. This point is going to be translated to here. So in orange, that is our horizontal translation. That is the function g of x is equal to sine of x minus pi over 3. So one way to think of that, we move this point, this main point, 2 to the right. We move this one 2 squares to the right. This one went 2 squares to the right. This one 2 squares to the right. This one 2 squares to the right. What are the domain and range of the new function? So again, domain, it's still going to be the same. It's just all of x is an element of all real numbers. The range, this time we didn't move it vertically up or down. So it just goes as high as 1 is the highest number and negative 1 is the lowest number. So the set of y such that y is in between negative 1 and 1. And y is an element of all real numbers. The equation of the horizontal axis, that time it didn't actually move, so it just would be y equals 0. The amplitude would still be 1. And again, the period, 1 whole cycle, does still repeat in 360 degrees or 2 pi radians. So it hasn't changed, it's just shifted. So example 3, this is just asking you to write an equation for this. If we had f of x equals sine x, and it's been translated to the right pi over 6 and up 4, what would that new equation look like? So we'd have a new equation that might be g of x. We have a horizontal translation, so we're going to need brackets. It's going to the right, so we're going to have a minus sign there because it's the opposite of what you would think. And then plus 4 because we're going up 4 and we're going right pi over 6. Okay, last example, let's do 2 things at once here. So we're going to take the sine function, we are going to move it left pi over 4. Pi over 4 is the same thing as 45 degrees. And we're going to move it up 2. So you might want to do just one of those translations at once, but first we would graph our root sine function. There's my root function. If we have to move this to the left 45 degrees, remember if this is 90, 45 would be right in the middle between pi over 2 and pi, for example. That would be 45 degrees. So maybe that's what I would start with, is making this move pi over 4 units to the left. So there we see all of these points translated pi over 4 to the left. And then what we need to do is take that function that we've sketched here in purple and we're going to move it up 2 units. And that would be the graph of our new function. So what are the domain and range? Again, the domain is going to just go in both directions horizontally, so x such that x is an element of all real numbers. The range, this time, the set of y such that we are going in between 1 and 3. So the range is anywhere in between 1 and 3. If we look at our horizontal axis, it is moved up to y equals 2. And our amplitude, though, is still just 1. We're going up 1 unit from the horizontal axis to the maximum point. And the period is still 2 pi. What is different about this function here is that we did have a phase shift. A horizontal translation is also called a phase shift of negative pi over 4.